The JWST has undergone major redesigns and reconstructions through its 25-year-long planning and testing. With a budget of $9.7 billion and only has a 10-year lifespan. Why did NASA spend so much money on a very short-lived telescope? Hello everyone, you are watching Space Challenge X and today we are going to discuss about the James Webb Space Telescope. A very ambitious project of NASA with contributions from the European Space Agency and the Canadian Space Agency. The Space Telescope is named after James E. Webb, the administrator of NASA from 1961 to 1968 and played a very important role in the Apollo missions. The James Webb Telescope is a large, complex orbiting infrared observatory that will enable us to further extend the discoveries of the Hubble Space Telescope. James Webb has much more wavelength coverage and better improved sensitivity. The Webb has a very unique shape compared to other telescopes such as Hubble or Spitzer. This is because of its very large mirror array and its cooling systems. In fact, the octagonal mirror sits on the cooling system of the Webb. The James Webb was launched on board the Ariane 5 rocket of ESA. It operates 1 million miles from Earth. The Hubble Space Telescope opened new possibilities in space, but JWST is much more powerful and sensitive than Hubble, which gives us hope to find the answers to questions like, are we alone in the universe? The mirror is about 3 times wider than the Hubble Space Telescope. It will be able to see objects in the universe which are almost 10 or 100 times dimmer. JWST will be able to detect infrared light or heat. It can see or detect light that comes from the early galaxies about 13.7 billion years old. Due to its extreme sensitivity, the instruments of the Webb need to be very cold, about minus 220 degrees Celsius. JWST has its tennis court-sized sun shield to keep it cold and also to block the heat and background noise that comes from the sun, moon or earth. One of the most brightest objects that is visible for JWST is the planet Jupiter. L2 is also called Lagrangian point 2, observed and discovered by mathematician Joseph Louis Lagrange. Lagrange point is a place or a specific location in space where the gravity and the orbital motion balances very well. Hence, JWST is placed at the L2 point so that it can literally hover. Also, it will be hidden from the radiation of the sun, earth and the moon. Firstly, because of the L2 point and also due to its huge sun shield. JWST's mirrors are covered with a very thin layer of gold, but the mirrors are made up of beryllium. Because beryllium is lightweight, strong, dimensionally stable, but use of beryllium needs extreme care. It is brittle and very expensive too. JWST is huge, with a sunshield area of about 21.197 meter into 14.162 meter. But the size of the rocket flaring is limited. In fact, the Ariane 5 is the largest rocket and has a flaring size of 5.4 meter diameter. So, the JWST has a clever mechanism to be folded in the rocket but will be unfolded in the space like a paper origami. The Ariane 5 was a big contribution of ESA. It launches by first firing the liquid fuel main stage and then the solid boosters. There are 2 solid fuel boosters for the rocket, each weighing about 277 tons. After reaching 75 kilometers above the surface of the Earth, the boosters are jettisoned with only the main stage now working. After about 1 minute, the rocket is past the Kármán line. Then the flaring of the rocket is jettisoned because there is no more atmosphere. Eight and a half minutes after the launch, the liquid fuel main stage is also separated with the boosters and the flarings going to the ocean. Then the upper stage engine fires. The rocket is speeding up because in every last second the fuel in the upper stage is getting over. The upper stage is used to give a boost to go to the L2 point. Without the sun shield, there is nothing to protect JWST, so to spread heat as evenly as possible, the rocket rotates back and forth by 30 degrees. Plus 25 minutes, the upper stage cuts off, then is a coasting phase that lasts 2 minutes, in which the rocket rotates to avoid a collision avoidance maneuver. Then, the JWST separates from the upper stage of the Ariane 5 rocket. This is the last view of the JWST that we can see. Plus 31 minutes, the solar panel will be deployed. Plus 2 hours, a high-gain antenna is deployed. Plus 12 hours, there is a course correction burn. Plus 2.7 days, the sun shield pellet will be deployed. Then the mirror array and the instruments will be raised. Plus 5 days, the momentum flap will be deployed. Plus 6 to 7 days, the covers are released and the 107 sun shield release mechanisms work together to deploy the sun shield. Plus 10 days, the mirrors are extended and locked into place. Plus 11 days, a radiator behind the JWST is extended to cool the science instruments more. Plus 12 to 13 days, the wings of the primary mirror is also deployed. This is the final structural configuration of the James Webb Space Telescope. After all of this, the 18 mirror segments will be controlled with motors behind them to precisely arrange them to form a big, perfect mirror.